So moving forward, we have just a little bit left to talk about. We left talking about proteins. Okay? So what are the building blocks for proteins?
Acids.
A little more specific than acids.
Amino acids.
Amino acids. Okay? So how do you know that you are dealing with an amino acid? Because you have this middle carbon, and then what do you have on either side of that carbon?
Left side is a nitrogen with 2 hydrogens.
Okay? It's just habit. I put those dots on there, and that's called a what group?
Amino group.
That is an amino group. Okay? Then on this side, okay, what do we have on the right-hand side?
Acid.
Okay?
Double bond. Oxygen and that's the acid bond.
Okay. So on this side of the carbon, you have the amino side. On this side of the carbon, you have the acid side, hence the term amino acid. And this is the simplest amino acid. Did anyone write that down? Glycine. That's right. Okay, so moving forward. 20 different amino acids. You're responsible for 13 of them. Not this year. Not next year either. You're responsible for about 5. Oh, okay. The question was, does anything change on the outside? No. The NH2 group is always the same. The COOH group is always the same. The only thing that does change is when you start linking these amino acids together. But that means it has to start with that same base structure. Okay. So here again, we talked about these 20 different amino acids. And when you start linking them together, that's when you form complex compounds called what? Proteins. Okay? And if proteins is what makes up the bulk of our muscles, which they do, that seems like a really low number of your body weight. Because you have lots of water inside of those muscles, inside your body tissues. Heck, even inside your bones, you could say that. Because, you probably don't visualize this, but bones are connective tissue, not just because of the ligaments and tendons that are on there, but because of what's inside of the bones. Does anybody know?
Bone marrow.
It's bone marrow. The reason that is a type of connective tissue is because it produces all the different types of blood cells that you need, whether they're red blood cells, white blood cells, platelets, all of those.
I'm texting my mom that I'm not going to check me.
Why didn't you just ask, Tom?
What?
Why are you trying to hide it?
Why didn't you just ask?
Cause
Zach is probably will let you do it.
that's alright.
Well. I mean, are you done?
I mean, that's what I was saying. I put my phone down.
Okay. All right. Just a simple question. Are you done? Yes or no?
Yeah.
Okay. All right. Moving forward then. And it's these amino acids that deals with a whole complex process called protein synthesis. Because protein synthesis is what makes up your DNA. Okay? Or did I misspell that and say Dan? Oh.
Was DNA found in 1950s?
It was around 1956. DNA was found or discovered.
How do you find
See that
DNA?
video? I did not learn that. Like, from the video
Okay,
we watched.
sorry.
How do you even find DNA? Like, how do you just not know?
X-rays.
What's DNA stand for again?
Deoxyribonucleic acid. Okay? So one of the things that went through my mind, we took a short vacation, if you want to call it that, over Easter break and went down. And does everyone have the idea that I want to see the Grand Canyon? Is that just something? It's you're not wrong, because there's a place that you can walk to, you can hop a bus towards, and it's called the abyss. What does the abyss mean to you? A big hole, a big hole of nothing. It's just nothing down there. I mean, until you get to the bottom, that's what it means to be an abyss. And when you say, again, a big hole, that's pretty accurate. Okay? So the point we're trying to make here is, upon driving back to Phoenix, or Mesa, whichever you want to call it, from the Grand Canyon, I just looked up into the hills and think, man, back in the 1880s, 1890s, probably even 1870s, if you were a criminal, it probably was not that hard to get away. We look at confiscating criminals today because of the technology that we have. But maybe back then, again, in the Old West, we think, yeah, you just arrange a whole group of people and you all get on horseback and form your posse and go after looking for these criminals, outlaws, if you want to call it that maybe it's bank robbery, maybe it's various crimes, but it probably was not that hard to escape law enforcement. Now, when we look at the technology we have with this identifying criminals because of fingerprinting, of course, that was probably big back in the, I don't know, 1910s, 1920s, 30s. I guess I don't know when it became, let's say, mainstream. And what we mean by that is, we could say television was not really mainstreamed until maybe the 1960s. What that means is televisions were around in the 1950s, but they just were not that common because they were expensive. So when we say mainstream, that's when everybody probably has a TV, and probably still do. So with this, now we can go past fingerprinting and actually use viable DNA. And if the DNA is stored correctly, what may have been utilized at a crime scene way back in the 1920s, before DNA was ever, I wouldn't say invented, but discovered, you can probably still use some of that technology going back that far. But there probably really is no reason that anything would have been stuffed in a plastic bag from way back almost 100 years ago. Okay. So I want to do this one, then that will be it for today. So when you say, what is DNA? This is, of course, the real name for that. The D comes from that, okay? The N from the nucleic, and then A for the acid there. Now, we're going to learn why you call that deoxyribose here in just a moment. Yes?
What cells is DNA stored in?
All cells, anywhere from your skin or epithelial cells into your bone marrow, your muscle tissue. You learn a little more about that next year, because the reason that's so significant is these proteins that drive these chemical reactions for each different cell. your skin cell doesn't need the same hardware that your muscle cell does. Your nerve cell doesn't need, or neuron needs the same type of components that a skin cell or a liver cell or what do I want to say, a spleen cell. Of course, they all have their specific names because they all have different functions. So that's how and why the DNA is different between those, or the proteins are different.
So they all contain the same DNA, but only some are specialized.
Oh, I suppose. Because the DNA in each one of your cells can be used to identify you as an individual. That's you just do some sequencing on that. And that's where they possibly put one DNA strand on top of the other and say, yep, that's a match. Whether it's blood, whether it's skin, anything to that nature. Of course, that's way above and beyond my head. Okay, then, does everyone have this content that wants it? Okay, then we're going to talk about carbohydrates here in just a moment. A student is only as sharp as his or her pencil. This is pretty sharp then.
What about mechanical pencils?
Mechanical pencils are always sharp. It's just these. So if you have a sharp pencil, that must mean, yep, maybe we're pretty sharp. Maybe.
Mr. McKinney,
Yes, ma'am. Yes, ma'am.
what was your favorite subject in high school, other than science? My guess.
No, I wouldn't go that far.
World history.
Probably U.S. history. That and my least favorite. Probably foods and nutrition. Yeah. I don't know. I really didn't care for high school. I just can't imagine what it would be like to be in high school because we did not have this technology because it is so easy to say something or something about another person when you're looking at a TV screen or a phone screen. Typically, if you're going to tell something, say it to their face. Mm-hmm. Of course, sometimes that's easier said than done because even if you think, I'm just going to tell them to their face, I don't want to hurt their feelings. Okay, maybe, maybe not. Okay.
I'm gonna say something very mean to Anissa. Something very mean. Nobody stop me, please. Go for it.
That looks very complicated.
Well, it looks can be deceiving that this looks like it's complicated. I would suggest that you write this down though.
I don't think Preston knows what he's talking about.
I don't think it's an alcohol.
Because once you think this is an alcohol because it has OH group on it. But notice there's multiple OH groups on here. It's once we put this into a formula, you're going to look at this and say, oh,
Just hurts my brain.
that makes sense. Okay? So this, we could say is almost based on prior knowledge. So I'm going to flip this, just picture this like a hex note. a hex nut, and okay, so we have the same type of structure there, right? It's just that it's turned 90 degrees. Okay, so this is right here now because it's like if you had a hex nut, you turn it 90 degrees and now it's up top here. Okay, so again, this is based off of old knowledge because at the intersection of each one of these lines, what is occurring there? A what atom? No. Okay, with the exception of this one. Okay, now we're talking about this structure here now because this is an oxygen, not a carbon. Okay, so if we look at this, what type of atom would be on this point?
Carbon.
On this point.
Carbon. 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 Or would that be oxygen? Be carbon. Well, the other one's the oxygen.
Okay, and this is an oxygen. Okay, so now, how many carbons do you see up here? How many carbons do you see?
6.
Okay, that's the trick. Because there's 1, 2, 3, 4, 5. There's your sixth one. Okay, so let's count our hydrogens now. Okay, we'll just start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
13. 12. I knew that.
And then now count your oxygens.
1, 2,
1,
3,
2,
4, 5,
3, 4,
6.
5, 6. I think 6.
You have seen that before, you just don't realize.
So you just count stuff and that's it.
I know what it is. I know, but I don't. I do, but I don't.
Okay,
I really don't.
it's crystalline in structure.
Did we talk about it last time?
You are so close. It's not salt though, it's sugar. Okay, this is a molecule of not just sugar, but this. That is glucose. Okay? Okay. So, and I would suggest that you write this one down too.
Is it completely different from the other one?
You're going to see that here shortly.
Why is there an O like in the line?
Do you really want to know?
No.
Okay. Okay.
There is a quiz tomorrow. For
Okay, so left, right.
we have to memorize these.
No, I'm going to explain this here in just a moment. 'Cause I just need to double check myself. Okay. I was going to say maltose. That wasn't right. It's mannose, not maltose. Okay? So this is what we call mannose. So what can you infer from this to this?
Same thing, but there's one extra hydrogen and one less.
Everything is the exact same except for where is the OH molecule on carbon 2?
They're both switched.
Okay? So when you say switch, this one's down, but this one is up. This one is up. This one's up. Okay? This one's down. That one's down. So the only place that it's really different is right here. So since that is in a different location, that changes the properties of that sugar.
So it's like powdered
Those are exact isomers of one another because you could count all of these and get the same. You could get the same formula. Just that one of them, it differs right here. Okay? Then if you were to take this at the biochemistry level, then you're concerned about how this is pointed. General chemistry students don't do this either. We just point them down all the time. Because what happens is you either have that pointed up, and it's called a beta orientation, or pointed down, and what's called an alpha orientation. We just keep them down all the time.
So how do you write like that formula? Is it the same as glucose?
Mm-hmm.
It would be the same.
Okay. Then the last thing, some of the last things that we're going to want to do. And how would you know, other than memorizing these, how they're different? Okay. General chemistry has to do this. They have to take this information. Okay, don't write this down. It's just so you know where it's coming from. Okay. So they have to be able to transcribe what they see here into a ring structure. Then at the senior level, you have to be able to memorize this and be able to correlate this structure. Okay? That's why it's senior level. That's why we take this in a progression. You only have to be able to differentiate between, okay, this one's glucose, this one's mannose. Okay? For right now. Okay.
Wait, so what is mannose? Like what kind of food is it?
It's still sugar.
Like what kind of food?
It's just a monosaccharide. That's all it means. That's all you have to know.
Do they taste different?
No, I don't think they would. They might have a slightly different taste, but it's how these can link together to form disaccharides and polysaccharides. Yes?
Is brown sugar and regular sugar have different structures?
They're the same. It's just brown sugar has cinnamon added to it.
Perhaps. That's a question I really don't know. Okay.
Can I go to the bathroom?
Yes, sir. Okay, then finally,
There's just like one bit.
Why I missed you, by the way. No, I missed why it's supposed to. I missed why it's supposed to a lot.
Would you recommend us to write this down?
no, not at this time.
Oh, not this time? Oh, I just put the yolk.
Okay, what can you infer from those two structures?
They're the exact same. You're not much of an isomer.
The bottom right on the right
Say
side.
that again.
There are two hydrogens on the same.
Okay? So the reason this is important is this is the sugar ribose. Okay? This is a sugar called deoxyribose. So why would that be important? Where have you seen this before?
You have it.
DNA.
It's in DNA. This is where the D portion of deoxyribose, and there's the nucleic portion, and then here is the acid. So what we're saying here is this is the sugar portion that makes a DNA molecule. Then this is an intermediate nitrogen portion, and then this is the you could say the amino acid portion. So that's how and why this is called the way it is, because it comes from that sugar. Okay.
Can I quickly go to the meeting?
So that's all I have. We will catch up to you next time. We'll talk about some amino acids tomorrow, and then we'll talk more next week about when we'll get these exams in. Catch up to you next time.